Hello class, welcome to the next math lesson. We have finished the mid-module assessment for Module 3, and we're ready for the last half of this module. So this starts with Module 3, Lesson 8, called Similarity. And so you'll need pages 83 through 98 of your workbook. So make sure you have those with you. Make sure you have the materials that we use for math with you as well. Let's start talking about our notes with the road so far. What have we been doing so far this year in math? Well, in Module 2, we learned about rigid transformations. Please copy down these notes as I talk about them. If I go too fast, remember you can always pause the video to finish writing your notes. Module 2 talks about the rigid transformations, about translations, reflections, and rotations. We use those to prove congruence. Shapes were the same. Figures were the same shape and the same size. In Module 3, we've learned about dilations. In the first half of Module 3, we talk about dilating figures, changing the size, although the shape stays the same. So that's all about similarity. Similarity means the shape is the same even if the size is different. So those are the types of transformations we've learned about: translations, reflections, rotations, and dilations. In today's lesson, what we are going to do, we're going to use the rigid transformations and the dilations to prove similarity. We're going to use the rigid transformations and the dilations to prove similarity. So what we're going to do is we're going to move figures around. We're going to think about the figures. We're going to think about scale factors. We're going to think about dilations. We're going to think about translations, reflections, and rotations to try to determine if two shapes are similar, if two figures have the same shape. Even if the size is different, we're going to use all of our transformations to prove that the shapes are the same. Now, I do have a note I want you to pay attention to when we're doing this. The process for doing this, the first thing you should do is you should dilate to match the size first. And then after you dilate, you're going to use a rigid transformation to line them up. So match the size first, then use a rigid transformation to match figure to figure. So when we're doing the work today, dilate first and then use rigid transformations. I know that might not make sense right now, but that's why we're going to be doing some examples. So let's look at some of those examples and see why and how we dilate first and then use rigid transformations to prove similarity. That's what we're doing today. We are proving similarity. Again, if you need to pause the video to catch up on your notes, that's fine. You can pause, you can rewatch a little bit. Just make sure that your notes are complete before moving on to page 83 with me. So if you need to pause your notes, now is a good time while I go to page 83. So this right here is example 1 on page 83. Now let's read it together. In the picture below, we have a triangle, ABC, the original, which is blue, I'm going to say. I always like to color code mine. I think it makes it easier for you to see things. It makes it easier for me to see things. So if you like to color code also, feel free. So we have triangle ABC, which is the original figure, which I'm going to outline in blue. There we go. That has been dilated from center O by a scale factor R equals 1/2. And it is noted A prime, B prime, C prime. So let's do that one in green. So blue was dilated to make green. Blue was dilated to make green. And then we also have triangle A prime prime, B prime prime, C prime prime, which is congruent to triangle A prime, B prime, C prime. So we have those three triangles. We have those three triangles. Now, what it's asking us to do, describe the sequence that would map A prime prime, B prime prime, C prime prime onto A, B, C. So in other words, match this one with this one. How do I match red and blue? Match this one with this one. So that's what I need to do. I need to describe the sequence. So obviously you can see we need to change the size. So there's going to be a dilation. And we're probably also going to have to slide it over. So there's going to be a translation. But remember, we need our rules. So let's work on this. And if you remember what I told you to do, the first thing I asked you to do in your notes, what do we do first? It's in your notes. Do the dilation first. Match the size first. So we want to take the red and make it match the blue size. Well, to do that, we need to figure out how to reverse the dilation. Like the big one got made smaller. How do we move it back? Well, we know the scale factor to reduce it was 1/2. So to move it back, what we should do first is dilate by 2. Remember, if 1/2 shrank it, our dilation of 2 will move it back. So 1/2 made it smaller, r equals 2 will move it back. So step 1, dilate A prime prime, B prime prime, C prime prime from origin using r equals 2. Remember, you have to tell me the center. So I told you the center was the origin. And you have to give me the scale factor, which is 2. So dilate dilate the red, here I'll underline in red, from the origin using r equals 2. So let's draw where the new one is going to go. Let's draw where the new one is going to go. So this one gets dilated by r equals 2. And just like we learned in lesson 6, I can just do the coordinates. So A prime prime is 11 and 4. X is 11, Y is 4. So if R is 2, that means it just doubles. So 11 times 2 is 22. And 4 times 2 is 8. So the new one is going to be right here. This is actually going to be A prime prime prime. Because we have the original, the prime prime. This one's going to be prime prime prime. C also gets multiplied by scale factor 2. So C is at 15 and 3. So 15 times 2 is 30. 3 times 2 is 6. So C prime 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 is going to be right here. C prime prime prime. And I need to do B. B is at 13 on the X and 5 on the Y. So we multiply by 2. 13 times 2 is 26. 5 times 2 is 10. So B prime 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 is going to be right up here. So that is what I make after step 1, the dilation. That's only step 1. Remember, what it wants us to do is map A prime prime onto the original. Move the red onto the blue. I'm not there yet. I moved all the way over here. But now I am the right size. And remember, in your notes, we fix the size first. We fix the size first. The size matches first. So right now, I move this one, and made it right here. So I started with prime, prime, prime. Size matches. Second, then I use a rigid transformation to match figure to figure. So now I need a rigid transformation that will move this down over here. So if you look at that, what kind of transformation is it? That's not a rotation. I'm not spinning it over. It's not a reflection. I'm not flipping it over. This looks like I need a translation. I need to slide it over. So here's A, B, C. There's the originals. What transformation, what translation? It is a translation because I have to slide over. So step 2 is going to be translate. And now I need the rule because translate is only half the answer. What's the rule? Well, let's look at the A's. This A is at 22 and 8. This A is at 2 and 6. So to slide this A over here, I need to move down 2 units and left 20 units to make the A's line up. So translate down 2 units and left 20 units. And that will make them line up. And that is how you map the prime triangle onto the original triangle. So what you do, you dilate first by r equals 2. Where did the 2 come from? Remember, it's the inverse of 1/2. I did 2 because this is 1/2. So I made this, I took the prime, I dilated it bigger first, step 1. And then I slid it, I translated it over, step 2. And remember, I did tell you my rules. So I used r equals 2 for my dilation rule, and I used 2 down and 20 left for my translation rule. You can even, if you want, draw the vector for your translation. If you want to draw the vector for your translation, you can, and then you could just tell me where the vector goes. But that's the vector we have to follow. So the dilation, we follow r equals 2 because that's the inverse of what made it smaller. And the translation, we follow this vector, and this vector goes down 2 and left 20. So that is example 1. That's what we're doing today. You are proving that they are similar. So because I did this, I know that this triangle is similar to this triangle because I used transformations to make them line up. I used transformations to make this triangle line up with this triangle, so I proved they are similar. That's what we're doing for the lesson today. We're going to do some more exercises together. A little bit more practice, but that's basically what we're doing. And remember, the first thing we do is we dilate to match the size. So let's move on to page 84, exercise 1. A little bit of practice. Some triangles again. We have triangle ABC. Triangle ABC, which is right here. ABC. Let me highlight it so you know which one I'm talking about. That's triangle ABC, the original. Dilated from center O, okay, so O is the center, by a scale factor r equals 1/2. So the r is 1/2. And then it made A prime, B prime, C prime. So it made, after the dilation, it made this one. A prime, B prime, C prime. A prime, B prime, C prime. Now, another triangle, which we'll do blue. A prime, prime, B prime, prime, C prime, prime is down here. And we know that this triangle blue is congruent with green. So blue and green are congruent. And now it says, describe a dilation followed by a basic rigid motion that would map the blue onto the pink or the red. So again, we need to show that this one is similar to this one. Prove the blue is similar to the red. So I need to make them line up. And it told me that I need to do a dilation followed by a basic rigid motion, which means the dilation comes first and the other one follows. So step one, we're going to dilate. And then we're going to do a translation, reflection, or rotation. I don't know what it is yet, but let's do the dilation first, and then we'll make a decision. So now, how are we going to match the size? How are we going to match the size? Well, let's do dilate from the origin, because the center, we need to know where our center is, and dilating from the origin is the easiest. So let's dilate from the origin by r equals, what's r going to equal? Well, we know that up here r was 1/2 when we made it smaller. So to make these bigger again, we need to do r equals 2, because that is the inverse of 1/2. So dilate from the origin by r equals 2. So now we need to take this one and dilate it from the origin, r equals 2. So let's double all the coordinates. So a is 3 and 2. So a prime prime is 3, 2. So the new one is going to be 3 times 2 is 6. 2 times 2 is 4. So a prime 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 is going to be right there. B is 4 and 3. So that times 2, 4 times 2 is 8. 3 times 2 is 6. So B prime 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 is going to be right here. And C prime prime is 5 and 1. So that's going to turn into 10 and 2. So C prime 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 prime. Lots of primes. Let's connect our dots so we can see the triangle. And that is our triangle after the dilation. Now we're not done yet, because our triangle, we still need to map it onto the pink. We still need to move the new one onto the pink. So what rigid transformation, what rigid motion are we going to use? It does not look like a rotation. It does not look like we're spinning it, flipping it. It looks like we are sliding it. So we need to translate. So step 2 is going to be, we dilated first. Let's translate for number 2. Now, what are we going to translate? Well, let's get a vector. And just so that I don't cross any lines, I'm actually going to just do my vector by connecting the B's. I'm going to connect the B's. And that is my vector right there. That's the vector I have to follow to make them line up. So what's the rule? Well, the vector is going up. How many does it go up? It goes up 1, 2, 3, 4 to make the B's line up. So the vector goes up 4 units. So translate up 4 units. And then it's moving left. So how many left does it move? It moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 units up and 12 units left. And if we follow those directions, if we dilate the blue from the origin by r equals 2, and we translate up 4 units and left 12 units, this one right here and this one right here will be in the exact same spot. We just have to follow those 2 steps. So that's what we're doing today. Another example, they asked us to make sure to check if this one can line up with this one, and this one can. First we grow it, then we slide it. Dilate, translate. That's the order we follow. Let's move on to exercise 2. Remember, if you need to go back and rewatch any of this, you can always pause the video, go back and watch it again. But I'm going to keep moving on to exercise 2 on page 85. So exercise 2 on page 85, we have two triangles, and it's saying describe a sequence that would show ABC is similar to triangle A prime, B prime, C prime. So they want us to show that ABC and A prime, B prime, C prime are similar, which means, in other words, we need to prove similarity, which means we need to move them, change them to make them line up. We need to move them to make them line up. And we can do this. We can do this. I'm just labeling the colors so you can see better. Now, as you'll notice, they did not give us the scale factor. Like right now, remember step 1 in our answer. How do we prove? Step 1, the first thing we do is dilate. Now let's say dilate from origin, because that's always easier. But what scale factor do we use? They did not give us one, so we don't know what the inverse was. So we're going to figure this out ourselves. But this is easy enough because we are on a graph and we can measure. So we know AB is segment AB is 2 units. Segment A prime, B prime is this segment. So this segment was 2. This one is 1, 2, 3, 4, 5, 6. So that's 6 units. We also know that the dilation equation says the prime one is going to equal the original times the scale factor. That's our dilation equation. So we're going to use this information and the dilation equation to find R. A prime, B prime was 6. AB was 2. So we do some algebra, divide by 2, because 2 divided by 2 is 1, and 1 times R is just R. And if we divide by 2 on this side, we divide by 2 on this side, and 6 divided by 2 is 3. So the scale factor is 3. So 3 made this one grow into this one, because 2 times 3 makes 6. 2 times 3 makes this 6. And you can check it with other sides too. Like if you look at BC, this BC right here is 1, 2, 3 units. This BC prime is 1, 2, 3, 4, 5, 6, 7, 8, 9. That also follows the same scale factor. So let's use the scale factor to figure out where our new triangle is going to go. So what we're going to do, how will we make this match? So let's remember, first step, dilation, make the size match first. So we're going to use the scale factor 3 to make the size match. To make the size match. So let's do that. Let's take the blue and make it bigger. Now you're going to see right here that the graph they give us is not big enough to do this. But we can do the coordinates. We can use the coordinates. So let's dilate the blue one to make it the same size as the green one. Sound good to everybody? I'm just going to guess that you said yes, because you really don't have any choice. You're watching a video of me. So let us just focus on one point. Let's just look at point C. Let's just dilate point C. So C is -3 on the x and 0 on the y. If we change C, this one, by the scale factor, we get, let's do C prime prime equals R times C. So that's going to be the 3 times -3 and the 3 times the 0. So C prime prime, the new one is going to be -9 comma 0. -9 comma 0. So when we make this grow again, the C is going to be right here. Now, I'm not going to do B and A because those will fly up off the graph. But I know C prime prime is over here. But I remember I want, so we dilated from the origin, step 1, by R equals 3. Oh, I should say dilate triangle ABC, the original, from the origin by R equals 3. So after we dilate, this C moves over here. And it made like a super big triangle. We just don't have the rest of the triangle on it. So it's going to go like really big. It's going to go like right there or something. So we don't know where it's going to be because it goes off the page. But we only have to think about C. So we made this triangle bigger. Now we need to line it up with the green triangle. Well, let's just line up the C prime prime. Let's just move the C over here. So to do that, we're going to need to slide. So let's draw our vector that we're going to slide it. And there's the vector. What did our vector do? So step 2, we're going to translate. Let's see, the vector goes down. So it goes 1, 2, 3, 4, 5 units down. 5 units down. And the C moves, it moves 10 units right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 units right. Okay, so we dilated, and this C moved over here. We translated, and now it's down here. So now we get a triangle that looks like this. One looks like this, and it's going off in that direction, remember? So if this is the triangle going in this direction, we still need to make it line up with the green. How do we make it line up with the green? Well, you should be thinking, well, spin it, because we're going to spin it. We want to spin this line so that it lines up with this line. So we need to, the last thing we need to do, step 3, this is a 3-step one, rotate. And this right here, if you look, this goes straight up to straight left. That makes an L right here. We are rotating an L, which is that is 90 degrees. Rotate 90 degrees, and we're going we need to spin it this way, so it's moving in an L shape backwards from a clock. So we say rotate 90 degrees counterclockwise because it's moving the opposite way of a clock. So that's how you do it. So this question showed you how you can line them up even if you cannot see the new one. Like, remember, we matched size first. So we took the small blue one, we made it bigger, and the C moved over here. We dilated first, and the C jumped over here. Then we translated to line the C up with C, and then we rotated to line everything up with everything. So that is how we do it. If you need to watch that again, watch it again. If you want to set up a meeting with me to show you how to do that, we can do that. But let's move on to exercise 3 on page 85. It's asking, are the two triangles shown below similar? If so, describe a sequence that would prove they are similar. So are they similar? If they are similar, prove it. If they're not similar, tell why. So are they similar? And then prove it, or state how you know they are not. So let's start with the first one. Are they similar? You can look at these and try to figure out, but the best way to know, because you do not know if they wrote these to scale, the best way to do this is to check and see if the scale factor is true for all three sides. So let's check. B prime C prime is 4. BC is 6. AB is 10. A prime B prime is 10. AB is 15. AC is 18. A prime C prime is 12. So we need to see if these sides match. So we need to see if the same scale factor is used for all of them. So we need to take A prime C prime. We need to take AB, A prime B prime, and see if that's true. And we need B prime C prime to see if that's true. If all three of these dilation equations have the same scale factor, then they are similar. They all have to have the same scale factor to be similar. And it's very important that you make sure you're looking at the same sides. You have to have AC with A prime C prime, you have to have AB with A prime B prime, and you have to have BC with B prime C prime. You cannot switch them up. That's why I color-coded them to help me. So let's find the scale factor for all of these. Let's see, A prime C prime was 12. AC was 18. So I know I need to use my algebra and divide by 18 on both sides, because 18 divided by 18 is 1. And R times 1 is just R. And I get 12 over 18. Now that can be simplified because 6 fits inside of both of these. So if I take out the 6, I get 2/3. So this scale factor is 2/3, because 12, 18 simplifies to 2/3. Let's find the scale factor of the AB side. A prime B prime was 10. AB was 15. Do the same thing with my algebra. I have to divide by 15, because 15 divided by 15 is 1, and R times 1 is R. So I get R equals 10/15, which also simplifies. This time, on this one, I pulled out a 6 from both. This one, I'm going to pull out a 5, and I find out that this one also equals 2/3. Not good enough yet, because I have to make sure all three sides follow the same scale factor. So let's work on the BC. B prime C prime was 4. BC was 6. I'm doing my algebra, dividing by 6 on both sides, because 6 divided by 6 is 1. R times 1 is R. So I get R equals 4/6, which still simplifies. This time a 2. I can pull a 2 out from both of these, and I get 2/3. So I have the same scale factor for all three sides. So yes, they are similar. So that is the first thing I had to do. Yes, they are similar. Now I need to prove it by telling you how to line them up. I need to prove it by lining them up. So what I'm going to do, remember, I need to make the size match first. So size has to match first. So what I do, step 1, dilate triangle ABC by r equals 2/3, because that was the scale factor I found. If I dilate this by 2/3, it will shrink. And let me just pick, let's do from center A. So I'm dilating from this point A. So so now I shrink it. Now it moves from here, and it's going to look like this. So after I dilate it, it looks like this. Now, well, it looks something like that. That might not be perfect, but it's pretty close. Now, how do I move the pink, make it line up over here? Well, you should be saying, well, you need to slide it over, Mr. Baylor. So let's draw the vector we're going to use to slide it over. Let me just connect A and A prime. So step 2, translate on vector A prime. Now, after I do that, let me get my transparency so you can see. I take this triangle after I made it shrink, and I dilate it. And so I dilated it to make it shrink. And then I follow this vector A prime, to make them line up. And I'm going to label the points just so you can see. This is C, this is B, here's A. How do I'm not lined up yet. So I shrank it to make it go pink. I followed the vector to make the A's line up. How do I finish making it line up? Well, you should be able to tell from your practice in Module 2 that you need a rotation. You need a rotation. And if you rotate around point A prime, so we translate, and then we rotate around A prime to make them line up. So that's the step 3. Rotate around A prime. Don't worry about how many degrees to rotate for this. Just knowing that you rotate is good. So first, we dilate by 2/3 to shrink it, and we know it's 2/3 because we tested it. After we shrink it with the dilation, we slide it with the translation, and then to make them, and then to prove they are similar, to finish, we rotate to prove they are similar. And that's how we do that one. So this is getting kind of fun. You're kind of using the skills you got from Module 2. You're using the skills from Module 3. And it's kind of puzzle solving, figuring out which order of things to follow, how to do them. I'm having a good time with this. Let's keep it going. Little puzzle, problem solving thing. Let's look at number 4 on page 86. So number 4 is saying, are the two triangles below similar? Are they similar? So let me highlight them. So just like for number 3, are these similar? If they are similar, how do you prove it? How do you prove it? What sequence do you follow? If they are not similar, how do we know? So let's test the similarity first. Let's test the similarity first. So here's A prime, B prime, C prime. And here is the original A, B, and C. And so the first thing we need to do is we need to test our similarity. So remember how we do that? We make sure that the scale factor stays the same. We need to make sure the scale factor for all the sides matches. So let's look at side. So this side, I'll do red, and that's A prime, C prime, which means it has to match over here with AC. So this is 3. It also means that C prime B prime is 8, and that has to match with CB, which is 6. And it also has to, and then AB, which is 8, matches with A prime B prime, which is 10.67. Which is actually, by the way, just 10 2/3. So let's see if all three of these have the same scale factor. So let's do A prime C prime equals R times AC. Let's do B prime C prime equals R times BC. And let's do A prime B prime equals R times AB. And if all three scale factors are the same, it's magic. We're done. So let's try it. Let's try it. Well, let's see. AC was 4. A prime C prime was 4. AC was 3. So if I do my algebra and divide by 3, I get R equals 4/3. B prime C prime was 8. BC was 6. I need to divide by 6 to get R by itself. If I do that, I get 8 over 6 equals R. But that can simplify because 2 goes in 8 and 2 goes in 6. 8 divided by 2 is 4, and 6 divided by 2 is 3. So this R is also 4/3. Let's check AB. A prime B prime was 10 2/3. AB was 8. So I need to do divide by 8 to get R by itself. And you have 10 2/3 divided by 8, which the way you do this is you turn this into an improper fraction. So 10 2/3 is actually 32/3. And you divide by 8, which is the same as multiply by 1/8. You should remember how you multiply your fractions. If you don't know how to multiply fractions, make sure you talk to me about it. But if you do the multiplication, you find out that this R is also 4/3. So yes, it is 4/3. Yes, this is 4/3. So that works out pretty well for us because now we know the scale factors are the same, which means these two triangles are similar. So let's write that right here on the top. We're just going to write part 1. Yes, triangle ABC is similar to triangle A prime, B prime, C prime. Yes, they are similar. I kind of crammed that in there. Here, let me write it again bigger at the bottom. So, yes, triangle ABC is similar to triangle A prime, B prime, C prime. They are similar. Now I need to prove it by telling you what sequence to follow. So let's look at this and let's try to figure out what we're going to do to follow this sequence. How are we going to move it back to where it goes? So let's look at this and let's try to get them back where they go. The first thing we're going to do, let's multiply by 4/3. Let's multiply everything by 4/3. Now you're going to see this is a little bit tricky because the points are not exactly on. So the first thing we have to do, remember, always size first. So step 1 is always dilate. Match the size first. So let's dilate triangle ABC by R equals 4/3 because that's going to make it grow and match the size. So dilate by 4/3. So that's going to match the size. And I'm going to say from center, not the origin, from point C. If I make it from point C, that means that C stays in the same place. So C is just going to stay in the same place because that's my center. But I dilated by 4/3, which means this one is growing. This one is growing. So I made it grow by dilating it. And now it's going to look probably a little something like that. It's going to be about that. That's not exactly what it's going to be like, but that's going to be close enough. So I dilate it by 4/3 to make it grow. Next step, well, they're not close to each other right now. So what I should do is I should slide it over. And how am I going to slide it? Well, let's make a vector. Let's connect the C's. Because I kept the C in the same place, I just draw a vector to connect it. So I dilated, and then I follow this vector. So that means I'm sliding, which means I translate on vector, and the vector starts at C and goes to C prime. So as I translate on vector C, C prime, just like that. Now, let me get my transparency out so that you can see what I'm doing, because that's always more fun. This is a little puzzle. I'm liking this. So where's my marker? There it is. So I have this triangle that I grew. I have the vector I need to follow. Here's the vector I need to follow. So I dilated and it grew bigger. I follow the vector right here. Now, how, here's B, here's A, here's C. How do I finish making them line up? Well, it looks like if I flip it, it's not going to work because B is in the wrong spot. So it looks like what I have to do, I have to rotate, spin around point C prime. Bingo. Just like that. Perfect. Perfect. So here's what I did. I started with the blue. I dilated it by 4/3 to make it grow, and it turned, and I made the pink one. And then I translate on the C prime vector to move it over here. And then I start spinning. I rotate around point C prime, and they line up perfectly to prove the similarity. So step 3 is going to be rotate around C prime. And that is how you make the blue line up with the green. It's how you prove they are similar. You find the scale factor. It's all the same. You dilate to make one grow. You translate to slide over, and you rotate to line them up perfectly. And that's how you prove the blue triangle and the green triangle are similar. Those 3 steps right there. I'm enjoying this. This is like a little puzzle where you get to play around and figure things out. It's okay if you're taking some time to do this. This does take practice. This does take precision. You do have to focus and be precise. But I think you can do it. We have one more exercise we're going to do just to show. Oh, never mind. That was the last one. I thought we had 5. That was the last exercise. The next page has the lesson summary, which is just telling you exactly what we did. It just shows you that we are proving similarity. Just proving similarity. The exit ticket is on page 89. I'm going to slide that to the back because we'll talk about that at the end. Starting on page 91, you have your homework helper, which is a great tool because they give you an example problem. They show you the work that they do, and they tell you how to do it. They have little talking bubbles to show you how to do it. So look at the homework helper if you get stuck. The homework helper is on 91, 90, and 92, and 93. They give you another one that tells you how to do all this. Excellent. Your problem set starts on page 95, and this is going to be the exact same thing we did. We have triangle DEF. It was changed by scale factor r equals 4 to make triangle D prime, E prime, F prime, and you also have triangle, the prime prime triangle. It's just saying right here, they are similar, but they want you to prove it. Let me highlight it. The prime prime is right here. There's the prime prime. The original is this tiny one right here. And then, so original, prime triangle, and down here we have the prime prime. So that's the first one they problem set. What they want you to do, let me just turn this into simple things. They want you to transform blue to green. Move blue to green. Move blue to green. That's what you are doing. And remember, for your answer, first thing you do, dilate first. Match size first. Match the size first. Just like we did in the exercise. You can go back and watch the video if you need some more help. Page 96 has another question, number 2. 3 more triangles. We have triangle ABC, our original, which is right here. Triangle ABC. Scale factor of 1/2 to make the prime triangle, which is right here. And then we have another triangle, the prime prime triangle, which is over here. Describe the dilation followed by the basic rigid motion that would map the prime prime onto the original. So they're saying green, move green to the blue. Move green to the blue. And remember, the first step, step 1, dilate first. Dilate first. Move green to blue, dilate first. Number 3 is another question. Are the 2 figures shown below similar? If so, describe a sequence that would prove the similarity. If not, state how you know they are not similar. So, figure A is blue. Figure B will be red. Are these similar? If yes, prove it. If no, tell me how you know they are not similar. Problem set continues on to page 97. They tell you triangle ABC is similar to ABC prime. And then, so they want you to, they tell you they are similar, just prove it. Tell me how you move one onto the other. Prove it. And remember, step 1, dilate first. Use your transparency if you have to, but obviously you're going to dilate to match the size first. So dilate to match the size first. And then how do you move one onto the other? Number 5, so number 4, they told you they are similar. Number 5 is asking you if they are similar. So first, are they similar? Yes or no? If yes, prove it. If not, tell me how you know they are not similar. So if they are similar, prove it. If they are not, tell me how you know with evidence. Last page of the problem set, last question of the problem set is number 6. Describe a sequence that would prove ABC is similar to A prime, B prime, C prime. So again, how do you move one to line up with the other? How do you match one with the other? Remember, you need to make them match. And like everything today, the first step, dilate first to match the size. Match the size first. Remember, my answers to the problem set will be online. You just have to do the work. You can check the answers with mine. If you are stuck and you need some help, reach out to me and ask, and I will happily help you on any problem set questions you have. But check your work with mine and then ask me for help. On your exit ticket, page 89, you have 3 triangles again. Don't be confused. These are 2 triangles back to back. They tell you the scale factor. They just want you to tell me how to map the prime triangle onto the prime triangle. How do you do it? How do you move this one, the small one, to this one right here? I guess I can label it with you. So you want to move, how do you move red? How do you move red to blue? So that's the exit ticket. My lines are a little bit blurred. There we go. That's a little bit better. So you need to prove to go from red to blue. You are going from red to blue. How do you do that on there? Take a picture of your exit ticket once you're done to show me you know what you're doing. Have fun today. It is a little problem solving. It might take you some time, but you can do it. I have confidence. Just play around with it, figure it out, and remember, I'm here for any help you might need.